Hello everyone and welcome to today's interview preparation session. In this presentation, we are going to cover two very important and frequently asked questions from the fields of deep learning and machine learning. The first question is about how object detection is performed using convolutional neural networks, commonly known as CNNs. The second question is about loss functions in logistic regression, specifically whether we minimize or maximize the loss during training. Both of these are core concepts that interviewers love to ask. So let's break them down clearly and completely. CNN based object detection. Let's begin with the first question. How is object detection done using CNN? To understand this, we first need to know what a CNN actually does. A convolutional neural network is a type of deep learning model that is specifically designed to process and understand visual data, that is, images. When an image is passed into a CNN, the network's convolutional layers scan the image and automatically extract meaningful features from it. These features start from very basic, low-level patterns like edges and corners in the early layers and progressively build up to more complex, high-level patterns like shapes, textures, and eventually entire objects in the deep layers. This feature extraction ability is what makes CNN so powerful for image-related tasks. Now, object detection is not just about recognizing what is in an image. It also requires identifying where in the image the object is located. This is what makes object detection more challenging than simple image classification. To handle this, CNN based object detection models use either a sliding window approach or a region proposal method. In the sliding window approach, a fixed size window is moved across the entire image at different scales and positions, and the CNN checks each window to see if it contains an object. In the more efficient region proposal approach used by models like RCNN, the algorithm first suggests a set of candidate regions in the image that are likely to contain objects. And then the CNN only processes those specific regions rather than scanning the entire image. Several popular deep learning models have been built on the CNN based object detection framework. RCNN region based convolutional neural network was one of the first, followed by fast RCNN, which made the process significantly faster by sharing convolutional computations. YOLO, which stands for You Only Look Once, is one of the most widely used models today because it processes the entire image in a single forward pass, making it extremely fast and suitable for real-time object detection. SSD, single shot multi-box detector, is another fast and accurate model that detects objects at multiple scales in a single pass. Regardless of the specific model used, the overall process of CNN-based object detection follows three fundamental steps. First, the input image is fed into the CNN, which applies multiple convolutional layers to extract rich features representations from the image. Second, the model identifies regions within the image that are likely to contain objects and classifies the content of those regions. Third, the final output is produced, which includes both the bounding box coordinates, a rectangle drawn around each detected object showing its location and size, and the class label, the name or category of the detected object, such as car, person, or dog. In summary, CNN make object detection possible by combining powerful feature extraction with spatial localization, first understanding what the image contains and then precisely identifying where each object is located within it. Now let's move on to our second interview question, which comes from the fundamentals of machine learning in logistic regression? Do we minimize or maximize the loss function during training? This is a very straightforward sounding question, but it tests whether you truly understand how a model learns and what role the loss function plays in that process. Let's explore this clearly. Loss optimization in logistic regression. The answer is that in logistic regression, we always minimize the loss function. But to understand why, let's first understand what the loss function actually represents and how it is used during training. Logistic regression is a classification algorithm that is used to predict the probability of a binary outcome. For example, whether an email is spam or not spam, or whether a patient has a disease or not. To make these predictions, logistic regression uses the sigmoid function, which takes any real valued input and squashes it into a probability value between 0 and 1. So when you pass your input features through the model, it produces a probability score. Say 0.85, which means the model is 85% confident the example belongs to class 1. Now, the loss function is the mathematical measure that tells us how far off the model's predicted probability is from the actual true label. In logistic regression, the specific loss function used is called log loss, which is also known as binary cross entropy loss. This function penalizes the model heavily when it is confidently wrong. For example, if the true label is 1, but the model predicted a probability were class to 0, the log loss will be very high. Conversely, when the model's predictions are close to the true labels, the log loss will be very low. The goal of training the logistic regression model is to find the optimal set of weights. The parameters of the model such that the total log loss across all training examples is as small as possible. This process of finding those optimal weights is done using an algorithm called gradient descent. Gradient descent works by calculating the gradient or the slope of the loss function with respect to each weight and then updating the weights in the direction that reduces the loss. This process is repeated iteratively step by step until the loss converges to its minimum value. To put it simply, the loss function measures how wrong the model is. During training, the model continuously adjusts its internal parameters using gradient descent to reduce this error as much as possible. The lower the loss, the more accurate the model's predictions are. This is why we always minimize the loss, because minimizing the loss is equivalent to maximizing the accuracy and reliability of the model's predictions. The key takeaway in logistic regression, the loss function is specifically log loss or cross entropy loss is always minimized using gradient descent, and this minimization process is what drives the model to learn and improve its predictions during training. Thank you.